So in today's video I'm gonna take a look at charging back to your starter battery. So why would you need to do this? Well, that's a really good question, but for those of you who've been off-road, especially with modern vehicles, you start to realize that there's going to get a drain on your starter battery when you're camping overnight or even not moving the vehicle for a couple of days. So all vehicles will have a slow voltage draw on your starter battery when you're standing. Historically that's been pretty small, so up till modern vehicle days, if you went away on a week, 2 weeks holiday, you'd usually disconnect your battery or put a trickle charger on it. So it's now become a bit more of an issue with modern vehicles, and I'll give you an example with vehicles with powered tailgates, for example. So every time you open the back, you're pulling down on your starter battery. Now, once or twice that's fine, and if you drive off, not an issue for day-to-day use. But let's say, and from my own experience, I've got another vehicle with a powered tailgate, and that vehicle, we went away for a long weekend, so 2 nights camping. Into the second day, I started to realize the main battery was going flat or losing charge. So what do you do if your fridge is in the back of your vehicle? Do you leave the door open all the time, or do you just keep opening and closing it? Now, the reason why I sort of was living in this conundrum of what's the worst of the options would be that modern cars now have LCD displays as well, so when your back door's open, the whole display is on telling you the back door's open. No longer is it just a dashboard light. So now you're powering either a LCD display or a motor to open and close. So which is worse? I took the option of the screen would be less current draw, left the back open, fridge was in the car so we could get in and out of it whilst we're camping. Next morning, after 2 nights and 1 day, only 1 day, so I would say 36 hours, there was not enough current in the starter battery to start the engine. So that quick it went down. So yeah, look, luckily I had solar panels of somebody with me, so borrowed those, put them on, charged up the battery. But point here is that modern vehicles now, the current draw on your starter battery is now becoming significant. So you've got detected keys, the keys that you don't insert anymore. So that's using current to send out and receive signals permanently. You've got a myriad of things now pulling down current from your starter battery. Anyway, enough said on all that. You get the point. The point is that no matter what, this is now becoming an issue for most people. So my vehicle is a Prado 150. I'm really lucky that it doesn't have a powered tailgate. In fact, that was one of the reasons why I chose it. However, it has a single light on the dashboard when the back door's open, very small. Current draw is probably only going to be less than half an amp, a few hundred milliamps maybe, not even that. But still, over a period of time, I have noticed that it just pulled down on it. So I've got a dual battery system, as you can see here. Dual battery, and I've got solar. So the problem really is that when we're off-road, we run the fridge off the second battery and our lights off the second battery, and I've got a BCDC 1225D, which is the Redarc unit, which takes my solar and charges the auxiliary battery. And of course, when we're driving, it puts power from your alternator, goes back into the main battery, and all good. Hey presto, life's good. But again, if you're staying 2-3 nights, I found that my voltage will drop on my starter battery. So how do you get back to charging your starter battery? So most BCDCs out the box will not charge back to your starter battery. So one option you've got, and what I've done up till now, is just swap the solar panel straight on through a regulator straight onto the starter battery and just whack it on there. Now that does work, however, there are some buts here. According to Redarc, one of the problems you have with this is that the BCDC now thinks it's getting voltage because it thinks the engine's running. So it now tries to pull down current to charge the auxiliary battery, because the BCDC thinks it's got enough voltage to work. However, it's looking for a higher current than most solar panels will draw, and I believe it's 20 amps. Not that my so the alternator will push to the starter battery, sorry. So that's 20 amps. And then of course your solar panels, unless you've got massive solar panels, are not going to be outputting 20 amps. So that's not going to work. And what happens is it cycles on and off. And it cycles on and off quite rapidly. I mean, I can't tell you exactly, it might be 30 seconds or more on, and then it goes off. And looking at my battery monitor, you can definitely see that it's doing that. And as to the details, look, I'm no expert from Redarc, but clearly it's probably not good for your BCDC device to do it regularly. I can't imagine seeing it fluctuate. And I guess the charging profile then is not great, because it's now fluctuating how it charges your battery, especially when it's trying to charge your auxiliary battery. Anyway, so that's the conundrum that you now face. So the other couple of options I looked at was, well, what happens if you put an isolator between the starter battery and the Redarc unit? So when you're parked up, you could isolate it, and then you could drop your solar panel onto it, which is one way of doing it. And that's probably an option, or you carry on doing it the way I'm doing it and you look at damage, or there is an option. So Redarc do an option, but yes, it's more kit, more dollars, but I quite like the idea of the set and forget, being able to plug in my solar, and what this does is they do a circuit, and I'll show you in a second, of how you, once your auxiliary battery is fully charged, how you push that charge or the current into your starter battery, so you top that up as well. Anyway, I'll show you what this looks like. So here is the diagram supplied by Redarc, and I'll put a link to in the description of where you find it on their website, because it's pretty hidden. Anyway, so what happens is, done normal operation, so you're parked up, you're camping, you got your solar panels out, you've connected them to your BCDC. Your BCDC now charges down to the auxiliary battery. Happy days. And incidentally, let's just have a look at some of the other connections here. So through the ignition, there is a relay here. Now, because if you're parked up and the ignition is off, there's no voltage on this relay, so this relay is open circuit. So there can be no charging back from the starter battery. The starter battery cannot give any voltage to the BCDC with the ignition off. So the ignition's off, solar's generating the power, auxiliary battery is charging, and here we have what we call an SBI 12, which is the smart isolator, the Redarc smart isolator. And what this is, it's a voltage sensing isolator. So as the BCDC charges the auxiliary battery, once the auxiliary battery reaches 13.7 volts, this senses that, and it says, I've reached 13.7 volts, I have a circuit to earth, which means it can participate in the actions. So because this is off, this relay is normally closed to earth, so that point in the middle there is actually earthing it with no voltage on the coil, and so that 13.7 volts is enough to trigger this, and it connects straight to the starter battery. So happy days, that will now start putting charge back to the starter battery, and obviously it only does that once your auxiliary battery has reached 13.7. If this drops below that during this period, obviously this will shut off to protect your starter battery, because you don't want to be putting voltage down from your starter battery if this drops off. Right, so now you're running, you're on the road, and your normal charging would be from your alternator, your starter battery, through to your BCDC. So what happens then is this ignition, once your ignition is on, energizes this coil, makes this connection, so that connects your starter battery down to your BCDC. Great. But what it also does is, because your ignition is also connected to the second relay, and it is in the normally closed, but once you energize the coil, it opens and it breaks the earth connection here. So this solenoid no longer gets an earth connection, it can't make a circuit, and so this solenoid cannot activate, so it remains in the open position once, no matter what voltage this reaches, because the ignition is on. And as I said, as soon as you take that ignition off, that solenoid comes into play. So that's how it works in a nutshell. There's a good description here at the top. It takes you through it again for those of you. This is a normal relay, and then this is a normally closed relay with a second contact. I'll take you through that right now. So box of goodies have arrived. I actually got these from Spares Box, found the best prices. So what do we have? This is the smart battery isolator, 100 amp dual battery. So this is what it looks like, with a set of instructions inside, but basically, yeah, not much to it. Just got to find somewhere to mount it in the vehicle. You've got your black wire is the earth wire there, and that's what goes to the solenoid, and then your sensor is so your sensing side is this side, and we just connect that. But anyway, we'll look at the wiring in a bit once we had a chance to get it in. Instructions, so interesting to see. I'm not actually open this, interesting to see if they've got any sort of instructions on dual battery. No, it talks about fusing, we'll come to in a minute, and then tells you what the sensing does. So the one nearest the little red box is the sensing side, so that's what they call the start in this. So this, remember, this can be used for other purposes, and that's your secondary side at the back of it. You've got your ground black wire, and then you've got an override wire. And again, there are some circuits which allow you to join the two batteries together to do jump starting, or if you're using your winch, and I might look at that as well at some point. And that means you can use both batteries whilst you're either doing the winch or the jump starting. You just need a momentary button for that, so a button that you have to hold in, you take inside, and you're able to press it and hold it in just when you need it, because obviously leaving them connected together is not a good idea. Incidentally, if you do go down that path, you're going to need bigger fuses than I'm going to talk about today, because I'm not planning that at the moment, although if I need to, I might replace the fuses bigger. So speaking of fuses, I do believe actually in using the correct fuses for this type of thing. So I got the Redarc Fuse Kit. This is actually the 60 amp one, so these are not big enough if you're going to jump start or use the winch. You need to go 100 amps. I'm only using the 60s for the purpose of putting the voltage back to the starter battery. There is a diagram here, but these are going to confuse you, because these are not actually what you need. You need the diagram that I showed you earlier. And then on top of that, we've got a couple of relays. That is that's a normally closed relay with a second pair of contacts for the open position, and then a standard relay here for the initial part for isolating the starter battery. That one incidentally is rated at 40 amps, and the reason for that is that the fuses between the starter battery and the Redarc are 25. It's only rated at 25 amps, so this is rated at 40 amps, so that'll cover. The big question really was about the rating for the other one, because it's actually only on the ground terminal. So whilst you should rate it the same, it's very difficult to get higher rating fuses, so that one's sitting at 30 amps. Anyway, so those are the bits. We're going to look at how we wire it up and what we do there. So come to fitting. So looking for a location for the solenoid. So what I'm thinking of is my Redarc sitting here in front. So I've removed the front cover, just show you. Remove the front cover, remove the plastic bit at the front, so I can get at it more easily. All comes off pretty easy. And I'm thinking, so where I've got this bracket, I could put it in the engine bay, but trying to avoid that if I can. And actually there's a couple of extra holes. So this is a standard Redarc bracket for the BCDC for this vehicle, which is a Prado 150. This is how it comes. You've got your obviously supporting rail here. There's actually a couple of spare holes underneath at the bottom, and if I put my hand behind there, there's nothing really in the way there, although I'm going to use the bottom one because it's quite close to the bottom of the BCDC there. And I'm thinking, yeah, I'm gonna screw it in there. I'm just gonna drill an extra hole so I can bolt it onto the bottom there, and it'll sit well out of the way in front of the radiator so it remains cool. And actually it's going to be close to the wiring loom, which is great because this is where I run my wiring loom between the batteries, obviously in front of the radiator to keep that cool. So I'm just going to drill another hole in the plate here. I actually can get my drill in here now. That's why one of the reasons why I took the front plate off, front grill off the vehicle, so get that in, make that hole, and then I can bolt that in there, and that'll be good to go. And then we start to look at some wiring. So managed to get the solenoid in, fits quite nicely onto that bracket. Now routing the wires through. So the red part is the sensing part, so that's where you sense your voltage. So that knows to go to your sensing battery. In this case, in the scenario that we're doing, this actually goes to the auxiliary battery because it's going to sense when that reaches 13.7 volts, and then it's going to switch over. So that's that one, and I've routed that, actually joined it with my other, I already see now, but my other cables from my BCDC in a conduit in here. Got that all through, all in front of the radiator quite nicely, so it keeps it away from the engine heat. So now what I've got to do, got that wire through to up here at the moment. Need to do the fuse and everything for that side. So yeah, still to do. I'm also picking up on an ignition. Now I actually decided to take the ignition from inside fuse box. I know I could have got it from this fuse box, but the problem with that is that it's very difficult to connect it and leave it nice and tidy and get the lid shut nicely. And here it's actually easier just to pick off something inside, and then I'm just routing that back of the engine compartment in a conduit there, and yeah, that goes through to the front. It's also helped me tidy up some of my wires that run across for other things, for lights, so I managed to tidy those up. So next job is I'm planning on fitting the relays probably up here somewhere. So I need to fit the relays. So next job now is to sort of build a loom for the relays. So we'll have a go at that. What I need to do is take a ground wire to the solenoid, that back to a relay. I also need to feed through the other electrical wire to the starter battery, so I'll build a loom with those two in, taking them down to the solenoid, and we'll put that in. So just putting in the MIDI fuses. So this is the original one to the Redarc BCDC. Actually that's disconnected, so that has to feed through the relay as such, and then the new circuit for going across to the solenoid needs its own fuse, which is going to go here. So I'm probably for the moment just going to strap it to the top of the battery next to this one. They're both on the top. I guess one day when I come back I'll build something better for mounting these, but don't really want to get sidetracked onto that now. And then obviously through the from the live terminal through the MIDI fuse now has to go down to the solenoid, which is coming up here. So I did make a bit of a mistake, but I guess it's like most projects, isn't it? You sort of learn as you go along. So I've managed to get the original relay in. So this is the relay now. That's wired back to the ignition. So I've got an ignition wire, as I said before, coming to here, and then I'll ground that for the coil, and then for the switch contacts, that's picking up the earth from the solenoid in the loom that I built, and that will switch through to earth for that link to earth the solenoid when the engine is off, as per the wiring diagram. So that's there's no real load on that other than earthing, providing an earth for the solenoid. However, what I made a mistake with was, so they suggest a second relay for switching the existing supply to the BCDC. So my original circuit for BCDC is coming around here, goes to original fuse, and then went straight down to the BCDC for charging auxiliary battery. But what they suggest is you put a relay in to break that connection when the ignition is off, so that you don't get any flow back during the charge back to this battery. So what the mistake I made was I just went for a fairly standard 40 amp fuse, thinking that 40 amps terminals would be well sufficient because the BCDC is only 25 amps. However, what I didn't really give any thought to at the time was that these spade contacts here, so whilst they're fine for the coil and low voltage, I'm not sure, I don't think they're suitable personally for connecting 40 amps to, well sorry, 25 amps in my case. So, and actually because of the weight of the cable as well, trying to connect that to a spade terminal onto there is near on impossible. And to be honest with you, if it's not tight, it will just overheat and it will cause issues. So I've ditched that idea. That's not a good idea. The better idea, and I don't have time for it now, is to get what's called a heavy duty relay. And a heavy duty relay has your main contacts are this type of ring connectors, so you can solder them on properly and then join them onto here. Heavy duty. There are some relays around about. They're a little bit pricey. If you go and get one quickly, you're going to pay $100 in Australia. If you go online, you can probably get one for about 60. You need to get a decent one. Don't buy a cheap one off eBay, because you know what, this is going to provide the circuit to your BCDC whilst you're out on the road, and I wouldn't want to have a cheap and cheerful one. So worth the extra money. So that said, I don't really have time and want to wait for that now, because I'm going to have to order something and take weeks. And to be honest with you, I've come up with a second option, and the second option is to put a manual switch isolator in there. A bit temporary for the moment, but it'll do the job. So basically all I need to do is, when I have to lift the bonnet anyway to plug the solar in, or my main solar anyway, and then I literally just flick this switch when I'm running the solar to break the circuit, and I can do it manually, and then obviously remember to switch it off. The only negative with this is if I forget to switch it off or close the contacts again when we drive off, then of course I won't be charging the auxiliary battery when we're driving, but that'll be my stupid mistake. Is it the end of the world? Probably not, if I do forget, because I've got solar anyway. So, but that's a temporary fix. I think what I will do long term is order the proper relay, heavy duty relay. I might put a quick link to something like that in the video, so you can see what I should have done first time round. But the problem for me is this all adds up. It just gets so bloody expensive. What you think starts as a simple trip, a journey on putting something in, you know, it ends up very expensive. Anyway, stop waffling on, let's move on. So yeah, let me solder. So I'm soldering these connections up, making them up now. So we're making up some fly leads here as well, bit of heat shrink on there, and we'll get going. And whilst we're on that subject, one of the most useful tools I've found when I'm doing my work on the vehicle is I had a lot of trouble with getting a bit of a torch, because you can't solder these with a normal soldering iron. You need a pretty powerful soldering iron to solder these. So what I use is I use a little hand blow torch, and this torch is actually pretty awesome. I had a lot of trouble finding a torch, and that's why I'm mentioning it, because most of them are, I don't know, something about blow torches, they all seem to be bloody rubbish or not suitable for this type of work. So you need basically a low powered one. The beauty with this is you can do it one hand whilst you're working on holding the loom or holding anything else, and literally just you've got your setting on the back there for the output power in terms of amount of gas coming out, and then you've just got ignition. So literally that's as easy as to turn it off. So it's great about this is you can go solder something and then forget it, and it's quite a nice small flame as well when you turn it down, and it's really that quick to flick on and off all the time. So I find that really useful. It's called a Hot Devil here in Australia. Very nice tool, well worth buying, and it's obviously fillable. You just buy a gas canister and you keep filling it up when you need it. So very nice. Alright, let me get on then, stop waffling. Let me get on and solder up a terminal. Excuse me. We'll solder up that terminal on the end of there. So I generally solder to give the electrical connection, then try and crimp it as well to give the physical connection. Solder is the most important from a point of view of maintaining good electrical contact. The physical crimping, I wouldn't suggest just crimping without solder, because the whole point really is to get a good electrical contact. The physical contact is important with the crimp as well, so you need to try and do both if you can. The only thing that you have to be careful of with these is that they've got a hole in the bottom, so I generally do it both ways. Put a bit of flux inside, put some solder in, get it going, and then you can solder in from the top, and once the solder runs out the bottom, you know you've got solder flowing through. Anyway, we'll move on and get on with it. So I've got everything in now. Managed to mount the switch onto the side there. Actually had to rivet it in the end because there seems to be a double skin here, which is on the Prado is too difficult to get through. I didn't want to force it. Anyway, I'll clean that up with a touch-up paint and stop any rust. Yep, fuse holders all in, managed to tidy this all up. So I'm just testing it now. I'll put the solar on. It's not really a very sunny day, but anyway, we are getting some action. So got my app running. Let me just get it going for you. I don't know if you can better see it, not really, I'm afraid. Let me see if I can tip it up a bit. Okay, so the two batteries are now actually charging. You can see that now. It did switch over fairly soon after I connected it. So the BCDC is showing that it's in solar and it's in a charging stage, so it's receiving solar and it's charging. The battery monitor app is showing 13 volts on both at the moment, so it's charging both 12.99, and I can see now that, and when I started it wasn't, but unfortunately, so I've got to show you through the grill. Let me try and get you in there somewhere. You can see that that is now glowing red, which means it's switched over and is engaged, so it's sending back charge to the main battery now. So that's all good, and obviously the switch at the moment is in the off position to break the circuit so we don't get a feedback again, straight back again to the BCDC for charging, so it thinks it's doing something else, and that's confirmed by the fact that it's showing solar as the source and nothing from the vehicle. It would light up the vehicle if it was detecting anything from there, so that's all good. So we seem to be good there. We will have to do a test in a minute to check when the engine runs that we get the engine profile operating. At the moment that seems to be working really well. Right, so we did the testing with the engine off, but as soon as I put the engine on, went into test, I realized there was a problem in that the solenoid didn't drop out. So anyway, cut a long story short, and here we are a little bit later. It's the joy of video. You missed the boring bits. So the initial relay out of the box, coil is dead short, and all it was doing was blowing the fuse that I put in for it. So this is a 5-pin relay, normally closed. Coil is 85 to 86, so if you measure the coil on this particular relay, the faulty one, you'll see from the meter reading it's basically zero. Basically we're on 200 ohms there. That's basically a short, blowing the fuse. So out of the box, so that was a bit irritating because you don't really expect a new relay to go faulty. Anyway, spares box say they're going to give me credit for it. Had to run out of the shop, find another one. I'll give you a quick example then. So 85 to 86 on this one. This side's again. You'll see there that we've got about 77 ohms, which is the coil, which is better. So we'll put it back in and start my testing all over again. So just quickly, whilst we're doing a bit of testing, I've got a bit of a teaser for you. I want to know if anybody knows the answer to this, because it's beat me. So what I've done is I've connected, I've got my solar coming in, and actually this is just a link in parallel, so I can have more than one panel connected at a time. So literally this socket just loops back round to this plug here. Can't quite see it, it's all taped in, and then goes down to the BCDC, and then there's another wire that goes up to the roof to have a second input. That's all it is. So if I plug my solar into here, in theory it should go around there, straight into there and down to the BCDC. According to the BCDC, it's not receiving an input from the solar light's not on. However, if I literally break the connection going down to the BCDC, take that out, if I put in a meter, inline meter, so source goes to there, and I put that in instead between the two, like that. Obviously that's reading now really nicely. Now it works. Now I've got solar on my BCDC, and yeah, anybody can tell me the answer to that. I'll be very interested to know, because it's got me beat. It only ever works with the meter in line, and even if I take out the whole additional wiring, it's exactly the same thing. It only works with that in line. So it's almost as if the inline meter is doing something. Anyway, so we're back to testing, and we'll see how we go with the solenoid. So we can see that the Redarc is charging on solar now, and according to the phone app, we've got, we're going to lose screen in a minute, we've got 12.4, sorry it's not very good reflection, 12.4 on the main, that's not charging at the moment, saturation only 79%, I'll come back to that in a minute, and then the auxiliary battery is sitting at saturation 100% at 12.92 at the moment. So and then we look down to the solenoid, you can just see in there the solenoid has not triggered yet, it's not red, so it hasn't cut over yet, so we've got to wait for it to cut over, which should be very soon. Just want to touch on the 79%, and there's my problem. So my vehicle's been sitting literally just for 2 days in the garage, haven't used it for 2 days, and it's dropped down to 79%. Now I can't see any particular reason for that, other than the fact that, you know, your bits and pieces are drawing current, and there's the whole point of this system, is that when you're out on the road you can't afford that to start dropping like that. 78% in 2 days is quite a drop. I might have to do some more investigation to see why it's dropping so much, try and work out, but that's going to be really difficult to work that one out. Anyway, we'll keep watching this till it cuts in, and we'll see what happens. So it's just cut in, and you can see hopefully on the phone, try and get you in there, it is 13 volts now on the main battery, so the solenoid is cut across. You can just see the red light in there now, it's glowing red. Okay, the BCDC is still showing it's coming from solar, because obviously I've used my switch to isolate the BCDC. Yeah, I'm going to put a relay in there one day, but anyway, switch for the moment, manual switching. Back to the app. So we've got both batteries now getting voltage, so as well as the auxiliary being topped up, starting at 100%, we're now seeing the main battery receive some voltage and being charged. So saturation is at 77% at the moment. We'll hopefully watch that climb up a bit and see there, it's gone up to 78 already. So back up to 78 saturation, and hopefully we'll see it climb up. So that's the real proof of the pudding's in the eating there. So next test is now to start the engine and make sure that the solenoid switches off again. So now the vehicle's running. You can see the BCDC is taking its charge now from the vehicle. Solenoid has gone off. Good to say, solenoid is now off. And if we look at the app, it's obviously charging for both batteries now. So where we've got main battery receiving alternator charge, and the auxiliary is getting its charge from there as well, and the BCDC confirms that's coming from vehicle charge, because I put the switch back again. The switch here is back to the on position for my BCDC, and away we go. So that's it. Looks to be good now with the new relay. I'll just finish putting the relay in and insulating it a bit from the rest of the engine. Appreciate your time. Thank you for watching.